C programs have and use at least one function, the main function. This is where code execution starts. Just like all C functions, the main function has a data type, same as a variable. The data type reports what kind of value, if any, the function generates. For the main function, it outputs an integer value that is set at line 7 by the return statement. One thing to note is that the function's data type and its output must match. Let's look at this example. This particular example shows 5 functions, just like we saw earlier in the previous meeting. Each of a different basic type. Looking at this first one, the varchar function. This is a character function. It has a return value. It has a character return value. The val int is an integer function returning an integer, as you can see right there. The val float returns a floating point value. The val double returns a double precision. The void type function, the val void, returns nothing. It is void. It has no return value. Regardless of the type, C functions can return a single value. The return keyword is used, or the return keyword is what is used to send the value. The value can be a literal, or it could be a value held in a variable, or it could be a value returned from another function back from the calling statement. The main function returns its value to the operating system. Let's look at another example about arguments. Functions that accept input have values listed in the parentheses. These are basically called arguments. Looking at this repeat function here, it's an example that accepts a single argument. It's an integer value. If you consider line 15, the repeat function is called, its arguments are specified in the parentheses. It can be a literal value, it could be a variable, or just an expression, but the value in this function call should match the function's argument data type. In this case, the integer is used for the value of r, and therefore the function call takes in an integer value. A function can accept any number of arguments or none. Here, the total function, like we've seen, accepts 5 arguments, each having a data type and a variable name. The function is called in line 17. Function total is called in line 17 in the main function. It's called within the print function. The total function is a character function. It returns a pointer represented by this asterisk. It returns a pointer, a string. Its arguments are void, meaning that it has no arguments. It doesn't expect any, so the call to this function at line 16 right there shows nothing in the parentheses. The value entered from such a function can be used immediately, as it is in this printf statement, or it can also be stored in another variable since it's a pointer, or even discarded. This is how functions in C return values and deal with arguments. Let's see how a function is created. C offers no rules about when a function is necessary or required. It's best, however, to add a function when you use the same statements or perform the same process repeatedly in the code. For example, you could write a function to prompt for input that's prompted for several times. You could also build a function to handle a specific task. For example, a complex calculation. Doing so can help make your code more readable, and you can write a function whenever the mood hits you. Again, just to remind us, there are no rules. When you code a function, you set a data type for the value returned, or you use void if no value is returned. I'll go and say that. Then comes the function name. Functions are named just like variables, and they have the same rules. In the parentheses, you can set arguments. Functions with no arguments list void in the parentheses. A set of curly braces encloses the function statements. We're going to say that very shortly as well. So if you have curly braces, usually they enclose the function statements. Functions with no arguments, like we said, list void in the parentheses. Also, functions that have a return value must have a return statement to pass the value back to the caller. One more thing, functions must be prototyped, which introduces the function to a compiler. This way, the compiler confirms that the function is properly used. You have two choices when you write a function. You can write a function first in the source code before the function is called elsewhere, so you can start it within the source code at the beginning. Or you can write the prototype statement at the top of the source code file. We're going to see that shortly. This statement repeats the function declaration, but it's terminated with a semicolon. Let's look at this first example. In this code, the sum function returns no value and it has no argument. Void, void. It appears in the source code file before it is called in line 15. So it is its own prototype. If you build and run, there, so you'll end up with the sum function. So you notice that the sum function outputs this equivalent. This is what the sum function outputs. This is output by the main function. So in this example, the sum function returns no value, but it also has no arguments. It's void, void. It appears in the source code before it's called in line 15. So it is its own prototype. The sum function outputs the second line right there, and the third line is output by the main function. Program execution starts in the main function, even though it's not listed in the source code, and execution proceeds top down. We shall see that shortly. Let's see another example. Here is the same code, the same program, but the sum function appears below the main in the source code or in the source file. Because of this, you will require a prototype here in line 3. So this is what we call prototyping. The prototype statement repeats the function declaration. So this is the function declaration, but the prototype statement repeats the function's declaration. It's pretty much more like copy and paste. So you notice this is the same as this. So this is done when the function appears after the main function. So you need to prototype your function, and therefore it ends with a semicolon. By prototyping the function here, the compiler won't complain when the function is called at line 8 later within the code. By the way, the puts function is also prototyped. You notice in this code, because all functions must be prototyped. Where is this prototype? It's basically here. And so where is it kept? It's kept within the input output header file, the standard input output header file. A function prototype is simply the declaration of a function that specifies function's name, the parameters, and the return type. It does not contain the function body. The function's prototype gives information to the compiler that the function may later be used within the program. So it just alerts the compiler that I am going to introduce a function at a later time within the program. That's what prototyping is. So let's look at this other example. Functions can be called any number of times, which shows how functions work best. In this code, the press any function is called several times. So you notice, press any, press any, press any. It's called several times in the main function. Let's look at this other example. Here is the same code, but without the press any function. See the duplicate statements in the main function. When I see repetitive statements in this code, it should be the reason why a function should be used. So if you want to handle this kind of repetition or the repeated statements within your code, like you can see right here, this particular function, the press any function, handles the repetition and itself documents the code, but it also helps you save time when you're writing the code. So you just have to present the function and then write the statement once, and then basically keep calling that function whenever you want to use it. That's how functions help us solve a few problems or repetition within programming.